Here we have the stress strain graphs for cast iron, mild steel and copper. The yield point is where the graph goes from being a straight line to being a curve. Okay, the yield point in mild steel is quite obvious. It's where this jiggly bit happens. And it goes round in the cast iron. Young's modulus, E, that's just the gradient of the graph up to the yield point. If you're calculating Young's modulus using data from the graphs, make sure you take data from this side of the yield point. Beyond here, it doesn't hold true because Young's modulus, that's when you're using the steel or whatever within its elastic limit. Okay, if you load the copper up to the yield point and let go, it goes back to how it was. The same with the mild steel and the cast iron. If you load it beyond the yield point, when you let go, it's going to have stretched a little bit. There's been some plastic deformation. Up to the yield point, it's elastic. Beyond the yield point, you've done something plastic to it. You've changed it forever. Right. The yield point, the value of stress, is in the data booklet. The ultimate tensile stress value, which is the maximum the specimen, the material will withstand, is also in your data booklet. So you get that information from there. When you're doing stress strain calculations, my advice is you write down these 4 formulae and then you read through the question and write next to them what you know at the start. Okay? You'll find the UTS if you know the material in the data booklet. Again, if you know the material, E will be in the data booklet. One thing to watch is the unit for E in the data booklet is kilonewtons per millimetre squared. The value for UTS is in newtons per millimetre squared. I would change everything into kilonewtons per millimetre squared. So if this is 400 newtons per millimetre squared, that's 0.4 kilonewtons per millimetre squared. Okay. So write down the values the questions give you. Make sure all the measurements are in either millimetres or metres. Okay. Make sure all the measurements are in millimetres, and then you solve whatever you can. Take your answer, plug it into one of the other formulas, and solve again. That's quite straightforward.